Here's a rational equation which is somewhat more complicated than the previous one. And it reads 1 over x minus 3 minus 2 over x plus 4 equals to 3x divided by x squared plus x minus 12. All right, well, our first step is in order to find the common denominator, or the least common denominator that we're going to use to clear the fractions, we need to factor the denominator where it needs it. And it does over here. So we'll factor x squared plus x minus 12. And my problem becomes, and I'm going to leave quite a bit of space here, so in order to work, 1 over x minus 3 minus 2 over x plus 4 equals 3x. And this factors as x plus 4 times x minus 3. Alright, so you can double check that factoring. Not a surprise, I have x plus 4 and x minus 3 over here. If these were different from those, then this would turn into a really big problem, as it turns out. Alright, well, what is the common denominator? So the least common denominator, there are two different factors. X minus 3, x plus 4 are the two factors. So that forms the common denominator. I'm going to multiply each part of this equation by x minus 3, x plus 4. So I'm just going to write these in here. And I'm just about out of room over here. But now let's see what happens. Over here, the x minus 3's cancel. Here the x plus 4's cancel. And on the right's term, both these factors cancel entirely. So we did manage to clear the fractions here, as we're supposed to. And it's a little cluttered. I'm going to rewrite it carefully before I do anything else. And so I have 1 times x plus 4. That's just x plus 4. Minus 2, parentheses, x minus 3 equals to 3x. Alright, so one thing I want you to notice is that I use parentheses a lot. Parentheses group terms together properly, and they help keep you organized. If you're not organized in math, then you don't have much of a chance of doing well. So I find students who are lazy about writing parentheses usually do rather poorly. Alright, so in this case the parentheses is necessary because I have negative 2 times x minus 3. And boy, this is where people screw up. If you distributed through here, didn't write this step out, but went immediately from this step to the step I'm about to write, I find students very frequently mess up this distribution. It is negative 2 times negative 3. Well, that's a little easier to see down here. Since I rewrote it neatly, then there's probably less chance of making that sort of distribution error. Alright, so let's go ahead and finish this problem. I have x plus 4, distribute here, gives us minus 2x, and then plus 6. And please be careful on distribution, that's where I find lots of errors in this chapter. Equals to 3x. Let's combine terms here on the left side. This gives us x minus 2x is negative x, and 4 plus 6 is 10. And if I add x to both sides, then we cancel on the left. I have 10 equals to 4x. And then divide by 4. So x is equal to 10 fourths, but we can reduce 10 fourths. 10 fourths is 5 halves. So x equals to 5 halves. There we go. Some students would change this to 2.5, and there's nothing wrong with that, but going from 10 fourths to 5 halves is reducing a fraction, or simplifying a fraction. Changing it from 5 halves to 2.5 is just merely changing it from an improper form to a mixed form. And in algebra, we traditionally leave most fractions in as improper fractions instead of mixed fractions. So I would stop there. We can still check this answer. And here's, yeah, it's a little messy. Shall we do it? Let's go ahead and check it. Because I know some of you need the recap of arithmetic with fractions. So I'm going to erase all the work here and leave my answer. And just for the good